Assalamualaikum warahmatullahi wabarakatuh. Right, so today we're going to discuss on projectile motion. Okay, chapter 4. Right, so basically, projectile motion is very synonym in our life. Okay, projectile motion basically under the topic of motion in two dimensions. Okay, so if you recall from chapter 2, basically before this we have learned on motion, okay, involved in one dimension. Okay, so what you have learned in chapter 2 is that involving motion either in x direction or in y direction. Okay, so you have discussed motion involving object moving in x axis, okay, or motion moving in y axis. Okay, so these two type of motion only moving in one dimensions. Okay, whether it is only in x axis, whether positive or negative, or in y axis. Okay, so motion in two dimension will combine both axis. Okay, x axis and y axis. Right. So before we go further to the motion in in two dimensions, okay. So let's look on the position vector first. Okay. So let's say we have an object moving from A to B. Okay. So the displacement of the object is given by the vector R. Okay. So when the object is at A, it will have a vector displacement vector of Ri. Right. And as it goes to B, okay, through this path, okay, so let's say the object presented by my laser pointer here, from A moving to B, okay, along the path given. Right, so the displacement, all right, changes from initially at A, which is Ri, right, and then final dia become at B, which is Rf. Okay, so the change of displacement, right, from A to B, right, is equals to R final minus R initial, right, which equals to delta R. Okay, where delta R equals to R finals minus R initial. Okay, basically R ni is the distance from point A to the initial point. Right. So if you recall that I have given you example or I have explained the concept of displacement. Kan, let's say I have taken one object, the phone from your friends, right, and then I have moved it from one point and then going, along, long path and then at point B. Kan. So when the person realize that the phone has displaced, okay, he will not care how is the phone move. Kan. What is his concern is that last time the phone was at his hand, right, and then later the phone is then displaced at the final position. Same goes with R1 or Ri or R final ni lah kan, the displacement, right? So the object basically has displaced from the initial point into point A, kan? So that's why we have this displacement vector, and as it goes to B, we do not concern on the path taken by the object. What important is that last time it was here and then finally it was here along this displacement, okay, which is given by delta R. All right, so delta R is then equals to R final minus R initial. Right. So next is velocity vector. So if let's say this point tadi moving with a speed, I mean with a time. So as we analyze it with time, it will become a velocity. Kan as distance changes with time, it will become a velocity. Right. So to study the velocity, right, or to visualize what is velocity, let's say the object now moving from A to B here. Okay, so velocity is given by apa nama rate change of displacement kan, right? Velocity is the rate change of displacement, which is delta r over delta t, and v, right, or instantaneous v is then equals to the limit where t equals to 0, delta r over delta, I mean the delta r over delta e, so equals to dr dt. Kan, so if you want to visualize what does delta, I mean apa limit where t nearly or becoming zero ni is actually like this. Okay, so let's say now the object moving from A to B here, kind along this path where this path is not important lah, right? So the limit where t becomes zero is that when we repeat back, I mean when we reverse back the motion, okay, from B ni becoming back to A. Okay, so because at A ni time equals to zero, and then as time changes, the object move sampailah, sorry, until it move to B. Okay, so limit where t equals 0 ni is when B ni, we return it back until the 0. Okay, so if you study the line, okay, delta R ni, when it is at B, so it has this line. Okay, and then as it return to B prime, alright, so the line from here become like this, and then when it become double prime, it become like this, and then as we extend the motion until to 0, this line then become the green line. Okay, where it is actually the gradient of the line at point A. Right, so this line is actually V lah. Okay, so that's why we can say that dr dt ni is actually the gradient of the curve, right, at point A ni. Okay, or the tangent line at point A. Okay, so that is for velocity vector, right? And then the magnitude of the vector is given by V lah kan, where it is the modulus of V. Right, so if let's say we look into acceleration pula, right, acceleration also has the same concept where acceleration is given by the rate change of velocity. So if velocity pula changes, right, with time, then we will have acceleration. Just now velocity is the rate change of displacement. So when distance or displacement tadi changes, then we have velocity. Then when velocity pula changes with time, we have acceleration. Okay, so let's say we have a velocity punya graph like this. Okay, so at point A, velocity is the gradient kan, so it will have this line kan, which given by this arrow lah. And then at point B, right, it will have this line, which is the tangent lah kan at point B ni, which is this one. Okay, so the velocity, I mean the changes of velocity tadi will have the same concept where it will be the limit of apa nama delta V over delta T, where T becoming 0, which then equals to dV dt. Right, so apa nama the motion of two dimension, right, with constant acceleration basically is when we combine the analysis of the motion with x motion and y motion, right? So r, let's say the object is here, kan given by a displacement vector of r, where r ni basically consists of y motion and x motion. So we can write r vector ni, right, as xi plus with yj, kan, where I and j ni is the unit vector for both component x and y. Right, so the motion in two dimension, okay, basically is when we combine, basically is the motion that have both motion, y motion and x motion. This is what you have learned in chapter 2. Okay, this is a motion which has only one dimension, which is in this example is the x motion lah, kan, x dimension, okay, where it moves to the right. Two-dimension motion is when the object is moving moving forward and in the same time going up. So it has two motion. The object, okay, is moving forward. Okay, you can see from the next picture ni, the object keep becoming keep moving forward further, kan, right? And also in the same time it's going up. So this motion has two dimension, which is forward and also upward. So we can say this type of motion is motion in two dimension, okay, where it has associated with the motion of y and x axis. Okay, so to analyze motion in two dimension, all right, so let's say for v, can the kinematic equation for v we have learned in chapter 2 before this is equals to v equals to v naught or v final equals to v initial plus at, can, for constant a. So this formula will then have two axis lah. So we have to to analyze the motion this motion which we want to analyze ni. Okay, let's say we want to analyze it with this equation, right? So this equation we have to make it for x axis and y axis. Thus it will become vx equals to vx initial plus axt, and also in y punya axis vyf equals to vyi plus ayt. Alright, and combining these two in terms of vector unit, so we have v final equals to this equation in terms of I, and then the same equation in terms of y. Okay, so vxi vx initial plus axt unit I plus with vy initial plus ayt unit j, right? And then factorize ataupun rearrange balik in term of y and in term of initial and final. So we have vx initial I plus vy initial j, right? Plus with we factorizekan these two, can becoming this one, and then these two factorize can becoming this one, where t can be put outside, can. So axi plus ayj. Right. So in terms of the distance, okay, we have another equation, kan, right, where x delta x basically ataupun delta x equals to vxi t plus half ax t square, or sometimes you might written this. I believe you have written this way when you are in school, kan, delta x equals to vi vit, right, plus half at square, right, in school. So delta x ni basically is x final minus x initial, right? So x initial moving the other side, okay, and then it become equation downward too. Okay, become this equation lah. Okay, so x final equals to x initial plus vxit, right? So this is in term of x axis, and then this is the same equation but in term of y axis. Alright, so in term of the vector, the displacement vector r tadi, we can rewrite back this equation as r final equals to r initial plus vi vit plus half at square, kan, where r ni basically is these two lah, kan, or we can written it as like this. This is actually just to explain, right, where this equation is actually like this. kan. But we can simplify it in term of this one lah, where R ni kan is basically apa nama xi plus yi. Okay, and then VT ni is VTX plus VXT and VYT. Okay, and then A ni becoming AX and AY lah. Okay, so we apa nama we put it in term of I and J, right? Which then later can be apa nama rewrite as equation below here lah. Okay, so this is we factorize is in term of x in term of x y, and then vx and vy, and then the third ni lah half 80 square ni kan, this has half 80 square, so half and t can be taken out, right? And then this one for the second ni t pun can be taken out. Okay, so we can rewrite equation ni as this one. So let's see how this equation is used in example. Right, example 4.1, a particle move in xy plane starting from the origin at t equals to 0 with an initial velocity having an x component of 20 meter per second and a y component of negative 15 meter per second. The particle experiences an acceleration in the x direction given by ax equals to 4 meter per second square. Right. So A determine the total velocity vector at any later time. Okay. So the motion of the object will be like this. Okay, where it will have x motion and also y motion. All right. So this will be, I mean, the red arrow ni will be the combination of x and y motion lah sebenarnya. Right. So it will have sorry. Okay, so it will have an x component of velocity, which is 20 meter per second. So it will have ax represented by the purple arrow ni, which is 20 meter per second, and it will also have negative 15. So they forgot to draw that line. So let me just draw that line for you. Let's say green color. So this green color line ni represent the y component of velocity. Okay, so all these are negative 15. Okay, and then the x component is 20. Sorry. The 15 and 22 is the initial, right? So only the initial velocity. Okay, so only at initial point lah. Sorry about that. Okay, so initial velocity there is 20 meter per second, and initial velocity at y-axis is negative 15 meter per second. And then it also has an acceleration of x-axis, right? 4 equals to 4 meter per second square, right? And it doesn't mention anything on y-axis, so y equals to 0. Right, so determine the total velocity vector at any later time. So velocity vector last time is given by v final equals to v initial plus at square. Okay, where it is in term of unit vector is vxi plus ati plus with vyi. I mean basically this equation lah. Kan we just represent it in term of I and J. And then from the question, the information given is Vx initial equals to 20 meter per second, Vy initial equals to negative 15 meter per second, acceleration in x-axis equals to 4, and then Ay is equals to 0, doesn't given kan. So determine what just now the question, determine the total velocity vector at any later time. Basically, when it says that at any later time, the question asking for an equation. Okay, where equation is equation of velocity, must be in the vector unit, right? And it must have t, kan, in the equation, because t ni will be unknown lah, kan. It can be at any values. So that's what dia kata at any later time. So the equation must consist of t as the unknown, and then the equation is on v lah, kan, equation of v. Okay, so equation of v is this one. Okay, so we must put it in terms of unit vector. So it become like this lah, kan, this equation in I, and then the same equation in J, where J ni is all the Y, and then X ni, I ni is all the X. So put this information, right, into this equation, where 20 meter per second is xi lah, kan, vxi, and then negative 15 is vyi, and then 4 ni is ax, and then 0 ni is ay. Okay, put all these values, then we have macam ni lah. Okay, so 20 plus 4t, I negative 15 plus 0t, alright, which later then become is 1. So this will be our equation of velocity at any later time, because it has t dalam ni. Okay, so I hope you understand. If you have any question, just let me know. Right, so next question, B. Calculate the velocity and speed of the particle at t equals to 5 seconds, and the angle the velocity vector makes with the x axis. So now we want to calculate velocity, okay, and speed of the particle at t 5 seconds. So last time we have equation of this, of it, kan, at any time. So now when time ni equals to 5 seconds, so put 5 into this equation, okay, put 5 into the t tu, then we have macam ni, okay. So this will be the velocity in term of vector unit lah, kan, alright. 40i minus 15j, alright, and then the angle, so angle given by theta, right, equals to tangent inverse opposite over adjacent, where opposite there is y and adjacent there is x, right. So y tadi is negative 15, right, and then x2 is 40. Put the values, then we have negative 21 degrees. Okay, if let's say we want to find, sorry, it also asks for speed. Speed ni means the magnitude lah, kan. Velocity ni is the vector, which is this one, okay, and speed ni is the magnitude. So we have to find the magnitude, which is the modulus of v ni, by simply using theorem Pythagoras. Okay, so put this value into Pythagoras theorem. So we have 43 meter per second. Right, next, C, determine the x and y coordinate of the particle at any time and its position vector at this time. So sama juga, when it says that x and y means it asks for x and y, I mean in term at any time t, which means it asking for equation. Okay, so equation of x and y, basically these two are displacement lah, kan, or distance, kan. So basically it asking for the distance lah, ataupun displacement, right, at any time, which mean in the equation must have t. Okay, and then later dia minta juga position vector. Okay, right, so the displacement vector is given by r. Okay, so we use this equation, rf equals to ir, so ri ataupun delta r, kan. Okay, so delta R tu is R final minus R initial, where R initial tu moving in the other side here, right? So R final equals to R initial plus V initial T plus half AT square. So where this can be presented in terms of unit vector, okay, like this. So put in the values, right? Because initially the object is at initial, kan. If we look back the question, right, so starting from the origin, okay, so that's why ry initial and r final initial, right, is equals to 0. These two equals to 0. Okay, so Vx is 20 tadi, and then Vy, mana Vy? I think this is typo. This is supposed to be Y. Okay, so this is also RYI, VYI. Okay, this is also AY. So this is a typo because JNE is for Y unit, right? So sorry, yeah. Let me just write on top of it. So this is supposed to be Y. This is also Y. This is also Y. Okay, alright. So VY tadi is negative 15 and then AY 0 kan. AX is 4, VX is 20. Okay, so put it here and then apa nama? Um, this paragraph then becoming this one. Okay, so R equals to 20t plus 20t square, I minus 15t. So as we combine back, kan, mana yang 0 tadi taken out, right? So 20 and 15, 20t and 15t can be combined lah, kan? Okay, so become this. Right, so this is example for 4.1. If you have any question, you can text to me. Okay, just text to me. I will answer your question. Right. So if you don't have any problem with the example, then you please try this exercise. Okay. So pause the video and answer this exercise. And again, if you have any problem, you can just text me. Right. So if you don't have any problem, I mean, when you have done with this exercise, let's proceed with projectile motion. Okay, so projectile motion basically is a motion, like example, as you throw your basketball into the basket lah, kan? Okay, as you throw the basketball or as you throw any object, kan, like apa nama, baseball here or stone, or when you kick a ball. Okay, so all this motion are example of a projectile motion. Okay, where the motion will goes up and then goes down back. Okay, in the same time it will go forward. Okay, so yang basketball ni terbalik lah. Sorry. Okay, so motion is actually in this direction. Okay, so yang ni motion is. So basically projectile motion ni, okay, is a motion again, two-dimensional motion, which means it has y-axis and x-axis. Okay, so since it has y and x, so it will have a resultant vector lah, kan? So usually when we analyze projectile motion, we analyze it like this. Okay, so we draw the x component and the y component and also the resultant of the two component tadi. Okay, so let's say initially the object is here, kan, initial point where it will have apa nama, v initial in x axis and v initial in y axis. Okay, resulting in this direction lah, kan. So it move, I mean it will then have this direction, so the object move in this direction, and as it reach to B, okay, so it then has Vx apa in the same direction, and then Vy upward. Cuma if you see that, if you compare, kan, B and A ni, Vy is the arrow of Vy is shorter than Vy initial. Okay, this is because this object is actually behave as an object throwing upward. Okay, where we have gravitational acceleration downward. So gravity is basically an acceleration in y-axis, kan? Ni gravity downward. G ni is basically AY, kan, acceleration in y-axis, where it will change velocity, kan. Acceleration is the rate change of velocity, right? So let's say we have initial speed of y, okay, just now. Let's say Vy here is 20 meter per second, let's say, right? And just put G, sorry, just take G as your unit when you learn in school, kan, which is 10. Just to make our calculation simpler. Okay, so by having gravity 10 meter per second downward, after 1 second, let's say B ni is motion after 1 second. Okay, so from 20 meter per second, due to the gravity 10 meter per second downward, Vy after 1 second then become 10 meter per second. Okay, and then after another 1 second, okay, Vy then become 0. Okay, then after 1 second after that, okay, 1 second after that, Vy then become 0 plus negative 10. Kan, because every second it will have a change of negative 10. Okay, 10 meter per second downward ni means equals to negative 10 lah. Kan, meter per second. Okay, which means every 1 second, y will have a change of negative 10 meter per second each second. So that's why from initial ni, from 20 second, 1 second after that it become 10. 1 second after that it become 0. 1 second after that it become negative 10. Okay, meter per second. And then after 1 second after that it become negative 20 meter per second. Okay, so due to the gravity ataupun acceleration in y-axis equals to negative 10 meter per second square. Okay, so that is for y motion. For x motion, okay, apa nama, velocity x is constant. So that's why you see that the symbol it used is always Vxi. Kan, this is also Vxi because motion in x, the speed in x is constant. Okay, motion in x is constant. So that's why each motion ni, right? Each point, sorry, from A, B, C, D, E ni, Vx is always Vxi because Vx is constant. Okay, so this is projectile motion. So basically projectile motion ni is the combination, right? Is the combination of motion ups and down as you have learned in chapter 2, right? This is example 2.10 combined with motion in x-axis, kan, okay, as what you have learned in example 2.8. So basically we combine these two understanding, okay, becoming projectile motion. So the topic is actually not really hard. Okay, what you have learned in chapter 2, right? Example, what you have tried in example 2.10 and also 2.8 ni, you just combine it. Okay, these two phenomena also combine. Okay, projectile motion ni is the motion of an object going up. Okay, you see that the object is going up and then going down. Okay, so it will actually behave as example 2.10, right? And it will the object also in the same time moving forward. Okay, moving forward, which means it also behave as example 2.8. So the understanding of these two example or topics lah, we just combine. Okay, then it becomes projectile motion. So it's very easy sebenarnya. Right, so since it is a combination of these two topics, so the equation that you have learned during kinematic equation, can these two examples can be used lah. Okay, you can use this equation, alright. Cuma these two equation, this equation, all this equation, you must put it ataupun you must present it in term of y and x. Okay, so same equation now, we'll have y Y punya style, Y punya equations, and also X punya equation. Alright, so this equation in term of X and Y like this. Okay, combining with the fact for projectile. Okay, the fact for projectile is that acceleration for X is equal to 0. That's why Vx to constant. Kan, if you remember back this figure, okay, Vx ni is constant. Kan, this one is constant because it doesn't have acceleration in x-axis. Okay, so that's why it's constant. Because acceleration tu is change of velocity. So since a to 0, then velocity does not change lah. Okay, which is this one lah, kan? So ax equals to 0 becoming this one, right? And another fact is that ay, okay, is equals to negative g. So put this fact into this equation, alright? Then, okay, so ax then cancel, right? So because ax equals to 0, so all ax can be cancelled. Okay, so for equation x, since ax ni equals to 0, right? So this one is cancelled. So we have vx equals to vx final equals to vx initial. Betul lah? Kan? But this equation cannot be used lah because this is just a statement. Kan? Betul lah, since ax ni equals to 0, then v becoming constant. What is the meaning or apa, or the in other word, when ax is when vx is constant, vx final equals to vx initial lah. So this is just a statement saying about ax ni tadi. So this equation cannot be used, right? And then same goes with this equation, kan? Right? Since vx equals to vx initial equals to x final. Okay, so as we add these two values, they become 2v over 2, then cancel, kan? Then vx average equals to v lah. This is also a statement, kan? So this also cannot be used, alright? And then for this equation, so it doesn't have any a, right? So x final equals to, ataupun delta x lah, kan? Delta x equals to half v final plus v initial lah. So yang ni pun, right? As we combine these two, kan? So since these two are the same, so it will become 2v. So 2v over 2, then cancel. Kan? So we have basically here, if we put it here, then we have delta x equals to delta x equals to vt. Vxt. Okay, so we can use this equation, alright? And then this equation is actually the same as equation above. Kan, kau tengok balik. Alright, so this will become delta x, can, as this goes back here, and then this can be cancelled. So delta x equals to vxt. So these two equations are the same lah. Okay, same equation. And then this equation is also a statement. Okay, so yang ni is cancelled because a equals to 0. So we have v square final equals to v initial v final square equals to v initial square. Okay, so this is also a statement. So for x-axis, we have only one equation. Okay, so delta x equals to this is vx lah, vxt. Right, as for y equation, okay, so all the ay will become negative g. So change this into negative g. This one also change into negative g. Yang ni pun into negative g. So for y equation, we don't have any problem. We can use all of the equation lah, right? Because we don't have 0 kan. Ay ni change into g. Right, so later we can sum up, right, that the equation for projectile motion then kan being this lah. Okay, so for x equation we have this, which can be simplified as delta x equals to Vx t. Okay, and as for y equation, we have all this tadi. Okay, where ay tadi becoming g. So all equation become, most of the equation then become minus lah. Kan? So v final equals to v initial minus gt. Right? So vy equals to, this is actually average. Kan? V average equals to v initial plus v final square. Over 2. I find that in my experience, this equation is very rarely used. Okay, very rare we use this equation, right? So this is delta y equals to half vy plus v initial plus v final t. So sometimes we can use this equation, but these two is, 1, 2, and 3. Kind the first one and the last two equation are quite often being used. Okay, so delta y equals to v initial y t minus half gt square, and v square equals v final square equals to v initial square minus 2g delta y. Alright, so this will be the equation that we'll be using in projectile motion. So you have to memorize lah, right? And it's very easy, kan, because you have already memorized it in chapter 2, right? We just now have to make it as y component, right, with g in it, right? So it will be very easy actually, right? And then another thing, okay, if since I've mentioned earlier that projectile motion is the combination of motion throwing upward, kan, as example 2.10 kan, just now moving object moving upward and then falling down. So it will also have the same facts. Okay, remember that this example at point B ni, okay, or when the object reach its maximum displacement ataupun maximum height, okay, Vy equals to 0. Velocity at maximum displacement, maximum height ni is equals to 0. Okay, so remember this fact. Sometimes this fact can help you, okay, in solving the problem lah. Okay, and we can actually find the equation of maximum height ni and also maximum displacement, or we call it as the range. Okay, the range motion lah, or maximum x. Right, so to find the maximum height, okay, basically this is the process, but I think we can just skip this, where combining a few equations, then we will have this equation, okay, where h equals to vi square sine square theta initial over 2g. So this will be the equation for maximum height, okay, where vy at this motion, at the position is equals to 0. Okay, and we can also have an equation of r, okay, the maximum range ni. Okay, same process juga, we combine a few of the equation, right, and then we have this equation of r. Okay, where r equals to, or range ni lah kan, maximum displacement ni, or maximum x ni, x distance ni, right, is r equals to vi square sine 2gi over g. Okay, ataupun vi square over g. Alright, so next is trajectory. Okay, so trajectory, the projectile motion, okay, or trajectory lah. Trajectory also is another name for projectile motion, is affected by angle. Okay, so this actually, this facts is very important. If you know, you usually you will use this fact when you want to water your plant. Okay, usually you will be using hose kan, and the angle that you use to, okay, have effect with the distance. Okay, so the maximum angle that the angle that can produce the maximum distance is 45. You see, when the angle is very far, very high, okay, it will produce a very short distance. Okay, so angle of 75 ni is actually have the same distance x with angle of 15. Same with angle of 60. Will have the same distance with angle of 30 here. Okay, where the maximum trajectory or the maximum angle to produce the maximum trajectory is 45 degrees. Okay, this is all these are when v are same lah kan, when we have a same velocity initial. Okay, so to solve problems with projectile, on projectile motion. Okay, so usually when you read the question, you have to conceptualize it. Okay, whether it is a full projectile motion or maybe half projectile motion, right? And then look at the question and check whether the question are asking for maximum height or maximum range. Okay, if the question asking for these two, then use proper equation lah kan, as these two, right? Or if let's say the question asking for a different a different component, then you have to use the equation that we have introduced lah, okay, for projectile motion, which is these 6 equation just now, kan, where it has only one equation for x and the rest ni is equation for y. And remember, you have to treat the x component separately with the y component, which means you have to analyze separately the x component and the y component. Okay, and then next last is just apply lah. Okay, apply all this equation into your problems. Okay, so let's see. As example 4.2, the long jump. A long jumper leaves the ground at an angle of 20 degree above horizontal and at the speed of 11 meter per second. How far does he jump in the horizontal direction? So, how far does he jump in horizontal direction means the equation asking for the maximum range lah, kan, where the equation for range is r. Okay, r equals to v square sine theta over g, right? So v is given, right? So this is v initial, which means the resultant v. Okay, so speed of 11. So it doesn't say that this is x component or y component, meaning that this is the resultant vector lah, kan? So vi, right? And then angle there is 20 degree. Right, and then g is constant, so we only need these two facts saja, theta and also v. So putting this into the equation, then we have maximum range equals to 7.94. Okay, next is maximum height. Again, maximum height is h equals to vi square sine theta square over g. Again, it also need these two facts only lah, v and also theta. So putting these two into the equation, we have 0.722 meter. Okay, so again, if you have any problem, just text me. All right, and if you don't have any problem, you can proceed to the exercise. Okay, so I will stop my video here. Okay, so please do the exercise. If you have any problem, just let me know. Okay, Assalamualaikum.